Right, there we go. Okay, right. Hello everybody. Just really quickly for everyone who's here for the first time tonight, we're Glasgow University Real World Economic Society. We're a society that campaigns for pluralism in economics and for a reform of the economics curriculum. And to that end, we've been part of the International Manifesto that was published in May, if you've heard of that, and we've been holding guest lectures, reading groups, tutorials and all sorts of events on campus to give students access to different approaches to economics than what they get on their course. Tonight, for our Freshers Week event, we've got a very special guest that many of you will know from Economics 2B. His book, Debunking Economics, is a kind of sort of textbook in that. And it's really great to have him tonight. He came down, he came all the way from first New York and then from London. And he made it all the way to Glasgow. So tonight we've got Professor Steve Keen. And if you enjoy tonight's lecture, we've got sign-up sheets over there. If you just leave your email address, you'll be receiving our newsletter because we've got many more great events planned this year. Thank you.
Thank you. Well, thanks for the invitation. I'm very pleased to be here. It's for an economist, it's always interesting to find yourself at Adam Smith's university. So I might start with a quote from Adam. I'm going to be debunking economics, and I think actually if Adam Smith were in my situation right now, he'd be doing a similar debunking job himself, because if you take a look at the theory of value that's part of Smith's thinking, he ruled out the idea that utility plays a role in setting price. He comes up with the classical school of economics, which is very, very different to the neoclassical school that dominates the academic profession these days. Hang on a second. Let's see if that's going to happen. That doesn't mean a problem in my recording the screen here, but we'll soon see. Okay. So I'm going to go through the conventional theory of money to begin with. And by the way, the first half of the lecture I think will be, well, it's going to be complicated, but I think entertaining. The second half I'm going into conventional economic theory, and some of you should fall asleep during that bit. Okay, so if you start feeling that's starting happening to you, let me know. I might jump a few slides, but I want to cover a part of the conventional theory and why that's wrong. And the standard stuff you'll learn if you do a first-year course and carry on right to PhD as well, is that money doesn't matter in economics. This is one of the amazing things for somebody who doesn't do an economics degree. Everybody who doesn't do economics thinks economists are experts about money. When you actually do it, you find they're experts explaining why you shouldn't think about money in economics, which I think is quite remarkable. So the usual story told is just a veil over barter. And in fact, you can trace that back to Adam Smith. And that therefore means that when conventional macroeconomists model the economy, they omit banks, debt and money. Now I know that after the financial crisis, they're finally starting to look at one or two of the above three. But I've yet to see any conventional model that has all three in them. And I think the way they're doing it is quite a clumsy way of doing it. And one thing that they argued once the crisis had occurred, first of all, it wasn't going to happen. And secondly, when it did, they couldn't have predicted, and it wasn't their fault they couldn't predict it. I think that's quite unrealistic all the way around. So from my point of view, a realistic view of economics is that capitalism is essentially a monetary system. And trying to explain how capitalism functions without banks, debt and money is a bit like trying to explain how birds fly while ignoring they've got wings. So we live in a monetary economy, and in that monetary economy, financial crises are systemic. It's not the sort of thing which is just a shock that happens occasionally, can't be predicted, exogenous, etc., words that you'll learn if you haven't yet started doing an economics degree. You'll get that in your mainstream courses. But I'll go through and show why I believe they're wrong, and give a very simple demonstration of that as well. And then ask, well, is that all they get wrong? And actually, I think no, it goes all the way back to the foundations. Even this supply and demand analysis has got fundamental flaws. So the whole of economics needs to be redesigned. Whether it'll get there, I don't know. So Adam Smith does play a certain role, even though I'm saying he'd be a critic of the conventional view today, because he differs on where he sees value coming from. He was the one who coined this phrase about humanity, saying that the propensity to truck and barter is something that is unique to human beings. And the classic phrase in his book saying that it's common to all men, everybody does this, so he says, but no other animal does. And a classic phrase, no one ever saw a dog make a fair and deliberate exchange of one bone for another with another dog. Okay. Well expressed. Wrong, as it happens, but well expressed. Not about dogs, but about humans. I'll explain why shortly. So that's the origin of the vision that money is just a veil over barter. Remove the veil and you actually see barter going on behind. That's the argument you'll get in conventional macroeconomics. And therefore, they leave banks, debt and money out. I'm going to quote my favourite neoclassical economist here. I actually sat in the room with this guy for the first time a couple of days ago in New York. This is from Paul Krugman. And in getting involved in a debate with me on the blogosphere about 2 years ago, he said that self-proclaimed true Minskyites, and it's definitely I'm one of those. Okay? Has anybody heard of Hyman Minsky? Has anyone not heard of Hyman Minsky? Hands up, come on, don't be afraid. Okay, search on him later. I'll give you a bit of background about him. He's an unconventional American economist who was ignored by the mainstream until after the financial crisis, whereas a lot of what's called post-Keynesian economics, anybody heard that term? Yep, okay. A lot of post-Keynesians are influenced very heavily by one of two people, often both of them, Minsky and Wynne Godley. Those are probably the two people who's deceased, but the two most recent contributors to that particular school of thought who have influenced the whole school of thought and how they try to build their theories forward. Anyway, they're saying that Krugman's saying here that self-proclaimed true Minskyites view banks as something that's somehow outside the rules that apply to the rest of the economy and have unique powers for good or evil. And he doesn't see it that way. He says, as most economists, and he's quite right about this, most economists are on the same side as him, don't believe they're particularly different. Banks don't create demand out of thin air any more than anyone does by choosing to spend more. So basically saying that we treat banks in the same way you treat any consumer going to shop. And he said he'll get the usual barrage of claims that he doesn't understand banking. He reckons I do, and it's what he called the banking mystics who believe that banks have some mystical powers for a different attitude. I'm going to argue that he's actually a barter mystic and try to explain why. So if his model was correct, however, if the vision that banks, debt and money don't matter, then you could forget about them, okay? If it's correct that they don't have any effect any different to any other agent, then why single them out? You can have a model of macroeconomics without banks because they're just like any other institution in society. And here's his argument. One thing I like about Krugman, if you read the neoclassical writers, it's often like reading a foreign language. But Krugman's actually like English. You can read him quite clearly. So he says here, think of it this way. When debt is rising, it's not the economy as a whole borrowing more money. Okay? There's no extra money being created by borrowing, in other words. It's just a case of less patient people who want to spend sooner than later, borrowing from more patient people. Quick question, who's the better person, the less patient person or the more patient person? Who's more ethical? What do you reckon? Who reckons the impatient person is a better person? Who reckons the patient person is a better person? This is supposed to be a value-free science, but the terms it's science too, I don't think it's a science at all, but a value-free discipline. But the words they use are pejorative. Perfect information. Patient versus impatient. Just be careful about the extent to which language affects how you think. Now, this is quoting from Ben Bernanke now, and Ben Bernanke was regarded by conventional economists as the expert on the Great Depression. I don't believe he is. But that's why he got the job as Federal Reserve Chairman. And the person who wrote one of the well-known arguments about why the Great Depression occurred was an American economist called Irving Fisher. And he developed what he called the debt deflation theory of Great Depressions. And here's Bernanke explaining why Fisher had an influence on Roosevelt and economic policy in the 30s, but economists didn't take him seriously. Most mainstream economists. He said his idea was less influential because of the counter-argument that debt deflation is no more than a redistribution from one group debtors to another group creditors. Now, what happens when somebody goes bankrupt, by the way? Do they pay their debts? They don't, do they? So how can they redistribute? Okay? Logical flaws like that, jumping over problems, is a common thing with the neoclassicals, but I'll jump past that. So he's saying it's a pure redistribution. Debt deflation simply means debtors transfer to creditors, even though they've gone bankrupt and don't pay their debts. And he says unless there's huge differences in how much they spend, then there won't be a big impact. and therefore we ignore Irving Fisher's explanation of the Great Depression. So I'm going to check this out by taking a model of banking which Krugman put together in an academic paper in 2012 and modeling it in a software package that I've invented called Minsky. I didn't write the code, by the way. I'm like the architect of a building rather than the bloke putting the bricks together. The guy doing the bricks is a brilliant programmer called Russell Standish, who's written this code as an open source software. If anybody wants to check it out after we finish the lectures, this lecture, you can go to that place called SourceForge. Just type the word SourceForge and Minsky into your browser. It'll bring up this page and you can download the software. So that's one way you can check out what I'm going to be showing you tonight. Okay, so what Minsky is something, again, which is very, very rare in economics. It's what's called the System Dynamics program. Now, I know that there's a course in System Dynamics at this university. Is anybody here from the System Dynamics group at Glasgow? Okay, I'm going to explain. Has anybody heard the term System Dynamics before? Yo, 1, 2, okay. Nobody else? Okay, I'll show you what it is. Because it's a graphical way of building models of dynamic systems. And if you imagine, who here likes maths? Good, okay. It's System Dynamics is for people who like maths but want to make it visual, in a sense. It's also for those who don't like maths and want to express things in what looks like a flowchart and still does mathematical expressions. So it's invented back in the 1950s, and it's absolutely the foundation of doing engineering these days. If you do an engineering degree, you learn system dynamics, particularly electrical engineering. And the packages that do this were the dominant one put out by a company called MathWorks with a package called MATLAB. You pay about $20,000 a copy for that software. And they've got hundreds of thousands of sales, so it's serious software. And it's also commonplace in sociology or the range of other programs. They all retail for about $1,000 or $2,000. Minsky, you'll be pleased to hear, is free, open source. What all of them let you do is build equations using a flowchart. So I've got this flowchart saying here, output divided by productivity is equal to employment. That little flowchart is exactly the same as having a set of equations like this. Okay? In fact, the software builds those equations for you. So if you wanted to build a complex model and then document it, Minsky does that for you. Now, that's overkill for a simple equation like that. You might as well just write that on a piece of paper. But it gets really essential when you get a very complex dynamic system because what they include is rates of change for a start. So what I've got here is saying, let's imagine you've got a constant amount of investment occurring. If you integrate investment, you're turning the flow of investment into the stock of capital. And that's what's going on with that equation. And then I say, well, if you divide that capital by a capital output ratio, you get output. And again, divide output by productivity, you get employment. And that's what's going on in those expressions. They use integration rather than differentiation for technical reasons. That little symbol there stands for integration. Okay, so that's how you, and I've got a few demonstrations on YouTube showing you how to build models in Minsky. So you do that, what you get is that set of equations, and you'll notice down here I've got the rate of change of capital is equal to investment. So this is what now is called an ordinary differential equation. And by ordinary, what it means is it involves only one fundamental variable, which is time. When you get more complicated models called partial differential, they have time and location, at least, as their other fundamental underlying systems. So you've got a rate of change being modeled, therefore you're talking about dynamics and change. And one reason I became the critical aim of mainstream economics when I was your age, long bloody time ago now, unfortunately, I'd learned differential equations at school. And to me it made obvious sense that economics should be taught using differential equations because we're talking about changing levels of output, changing population, changing technology. And I was stunned when I got to university to find there was none of this in what I was being taught. I only continued doing differential equations in my maths courses. So statics and equilibrium always seemed like nonsense to me. And that's why the software is being designed, to make it possible to do this with monetary systems. Now, you get extremely complicated models that can be built in this software, and I'll show you one which is one of my favorites. This is, have you heard the expression about a butterfly's wings flapping in China can cause a cyclone in South America? Okay. This is where that comes from, because a meteorologist called Lorenz back in 1963, I think it was trying to convince meteorologists that they should use nonlinear models. And the first thing he did was build an incredibly simple model of a pot of water on a stove. And the basic dimensions of this model, this has got 3 variables. I'll just make it a bit larger so you can see that on screen there more clearly. Just give me a sec to move things around a bit. Okay, so pardon, it looks a bit messy though. I don't know where that's where this is a developmental software, by the way, and occasionally bugs turn up. So that little box there shouldn't be there, and I can't get rid of it. I'm not quite certain why, but let's just see if I can redraw that too. Okay, this is an incredibly simple system with just 3 variables, x, y, and z, and 3 constants, alpha, sigma, rho, and beta. And what those 3 variables or the 3 parameters are like how wide your pot is, how tall your pot is, and how hot the hot plate is compared to the top of the water. That's all it is. And then what you've got is rates of convection. And the question is, at what temperature do you start get convection, and what's the pattern? How does effectively a single pit of water, how does it move in the XY plane in this overall pot of water? And here's what it does in equilibrium. And isn't that exciting? So you're right in the middle there, you can see absolutely nothing happening. What if I give it a bit of a shock? Now, you couldn't get a simpler system than this in some ways. Only 3 variables and 3 constants, and that's it. And in normal equilibrium thinking, it's a question of getting where the 2 curves intersect. But in fact, this incredibly simple system has 3 equilibria, all of which are unstable. But rather than breaking down and giving you crazy values, it moves around in what's called a far from equilibrium dynamics around all 3 equilibria. They're called strange attractors in the literature. And I could run this program for 1,000,000 years and it would never return to those 3 equilibria because they're all unstable. So you can't analyze the weather by working out where the equilibria are. In fact, the equilibria tells you where the weather will never be. Okay? Which is the same as doing it for economics. So what I'm trying to do is bring this sort of technology and this sort of thinking across to economics. And I'm far from the only person doing it, by the way. I'm probably one of the biggest mouth, but I've got plenty of colleagues who are doing this work who've always been in the backwaters of economics because we get ignored by the mainstream, who don't like non-equilibrium thinking and don't really believe, they actually believe in as many ways that you can model a system without presuming it's in equilibrium. In fact, the reverse applies in these systems. Okay? You model in equilibrium, you're not modeling a real system. I'll let that running. Actually, I won't let it run because it'll take too many processor cycles, but that's the sort of software that already existed before I designed Minsky. So the reason for building Minsky is that flowchart works really well for physical flows. That's just showing you like a drop of water buzzing around on a hot plate. But that's again, like say, imagine I'm modeling a car. Anybody got a car here built in the last 10 years? Almost without anybody? Some of you own cars. Okay. Anything built in the last decade has probably been designed in one of these software packages before the first piece of metal was cut. And they're things like you design how fast the petrol flows out of the tank through the injection system into the cylinders and so on. Perfect for designing that sort of thing. And engineers will carve off a bit of the process to one group and say, you work on that. Here are the inputs we're going to give you, the range of inputs. These are the outputs we want. Give us the mathematics of that. When it comes to computer technology, they actually then design the silicon directly from these software packages. And that's easy. One directional flow, you can break it into little units and so on. It's almost impossible to do this for financial flows. And the reason is that every transaction has effectively 2 directions. Like you've got to pay somebody out of your account into their account. Your account goes down, their account goes up. And it gets even more complicated than that, because first of all, you've got to make sure you use the right signs. Now, in doing the flowchart stuff, you can give a positive sign by accident to the 2 accounts, and the program won't stop you doing it, and therefore you get an error. Okay, and it's easy to get if you get the elements, not put the signs in, etc., etc. So what I did was borrow an idea from accountants, and really the person who inspired this was Wynne Godley, the other post-Keynesian I mentioned, double entry bookkeeping. Anybody studying accountancy here? No one? Come on, anybody? You are? Okay. How far are you into it?
I'm from the US.
Oh, okay. But you have done some accounting. Okay. I mean, I learned the hard way the importance of double entry bookkeeping. Only in building the software to get that I realized how important that was. But what you do with double entry bookkeeping, each row is recording one transaction, but it's got two accounts. And one you've got to give a positive sign to and the other a negative sign. So that way you make sure you don't make errors. Okay, that's the beauty of double entry bookkeeping. And that's what Minsky emulates as well by making sure that every row sums to zero. So imagine I'm just looking at a simple situation where one person is buying from somebody else by making a transaction from one bank account to another. Well, from the banking sector's point of view, I hope you can see that text there. I've got the reserve assets of the bank, so the bank's where the cash is held, and that's an asset of the bank. It's got the liability of your deposit account. So the money you've got with your deposit account is a liability of the bank. From that bank's point of view, it's a negative for the bank. So liabilities are shown as negatives. And if you make a transaction, the buyer, you have a positive amount added to the buyer's account from the bank's point of view because it reduces the bank's liability to the person who's done the purchasing. Their account's a smaller magnitude, increases the liability to the seller. That's a simple little thing there. That's just showing it from the point of view of the bank. You've got to also see it from the point of view of the buyer and from the point of view of the seller. And that's without bringing in the complication that you might bank with one bank and the seller might bank with another. So it gets even more complicated than that. Minsky makes it a breeze to handle all that sort of thing. So I'm going to use Minsky to model the way that Krugman thinks banking applies. And he literally uses this example in the academic paper of banking being a patient person lending to an impatient person, and the bank just intermediates between the two. It lines up a patient person and says, let's take $100 out of your account and give it to this impatient person over there, and then charges a fee for it. And if that was correct, if that was actually what lending was, Krugman and the whole neoclassical school would be right that banking wouldn't matter, and I'll show you why in a moment. So attacking me in my paper, this just turned up one morning, by the way. I woke up to find I was being blasted in the 8 pages of the New York Times. Quite intriguing. So in this paper he was critiquing of mine. He said that I assert that lending is an addition to demand. And that's a more complicated point than I've just written a paper, I think, finally proving that properly, but he didn't get it at all, he said. And here's his logic. If I decide to cut back on my spending and stash the funds in a bank, so he increases his own bank account, which lends them out to somebody else. So the bank takes your deposit, lends it to somebody else, which you'll be told is fractional reserve banking, another thing that doesn't exist. This doesn't have to represent a net increase in demand. He said, yes, it might, because the person getting the money may spend more rapidly. He said, but I seem to be saying something else, and he's not sure what it is. And he says, it's something to do with the notion that creating money equals creating demand. And I love how he puts this, but again, that isn't right in any model I understand. Very frank. He still doesn't understand it. He still defends his own model at this meeting I went to in New York 2 days ago. Okay. So what I'm going to do is model that, and I hope you can see the text there, because what I've got going on, I'm showing this in accounting terms. I've got credit and debit. That's a complicated thing. People that do accounting get used to this credit and debit. I find it really messy. I just prefer using plus and minus, and it works just as well. In fact, if anybody struggles through accounting, a little trick for you: write plus and minus and then translate later to credit and debit. You probably pass the exam more easily. So that's the case of lending from the patient person to the impatient person. So the first row says lending, and what you do is you write lend in one position, and as a positive, that's from the lender, and minus lend in the other, that's the borrower. So it's like a flow of electronics from positive to negative. And so on we go. I'll just explaining why I prefer to use the plus and minus here. Now, I'm going to change over to another program in a moment because the whole system looks like this. I'll take you through step by step. This is actually done in a table in PowerPoint so you can read the text more easily. So what's going on here, the very first row, that's the lending. And in the supplement to this academic paper, there's a fairly roughly written supplement to this particular paper which you can download. And in the paper itself, there's no bank. Lending doesn't include banks. And there's no money. But there is debt. People are lending each other bonds that they invent in a consumption good. But in the supplement, they actually bring in banking. And what they do is a more elaborate version. They say, well, it's not a patient person lending to an inpatient person. They say there's a consumer goods producing agent, and an investment goods producing agent, and the consumption good producer lends to the investment producer. And then they have all this strange stuff called representative agents and stuff like that, which I regard as total nonsense. So I don't reproduce that. But what I've got is, I've got an investment goods sector and a consumer goods sector, and workers, whom they both hire, and the bank. And that's a little model here. And I have lending going on as lending being a transfer of money from the consumer sector's bank account to the investment sector's bank account. That's the first little act. And then you can see repayment goes in the opposite direction. That's here. And then you pay interest. So interest goes from the investment agent across to the consumer agent. Then because the banks actually arrange this, you pay the bank a fee. That's how the bank gets some cash. And then the consumption sector hires workers. The investment sector hires workers. The investment sector buys consumption goods. The consumption sector buys investment goods. And then the consumption sector hires, the workers consume, and the bankers consume, and the bankers also invest. That makes sense? It's actually quite easy to read that, isn't it?
There's no time.
Pardon?
There's no time.
Time?
Yeah, instead that all this consumption at a point of time, or
It's at a point of time.
So
There's differential equations behind all of this. Yeah. So it's all with the time. Yeah. This is the words lend and stuff like that are just labels, which don't have a definition until you provide a definition for them in the program. And I'll show you that now. Let's go across to the program. So that's what I've shown you there is the model in Minsky, and I'll just dive inside this table here so you can see it. So it's hard to read the scale. That's why I made it larger in PowerPoint. But the table I've just shown you a moment ago is precisely that table. And notice I've got lend, etc., etc. If you come down here, you'll see I've defined lending as being a flow of money coming out of the deposit account of the consumption sector. That's what all these definitions are here. You can move these bits and pieces around. You can delete them. You can put extra terms inside there. I can change what that is. It's all done graphically. Now, but anyway, I've set that up, and that's Krugman's vision, which is a very neoclassical vision of what lending is like. So let's run the program, and I run it, and notice the big things down here. I've got the D is the level of debt and the money stock, and down here I've got GDP. Now, of course, I explain in an academic paper, which I'll put up on my blog shortly so you can see the overall logic, but I can derive GDP out of that model. And the argument that Krugman is making and the neoclassicals make is that lending has very little impact on GDP. Okay? Yeah?
you have two goods.
Pardon?
You have two commodities.
Two commodities, yeah, consumption and investment.
So and you're using one single unit of account to measure values of this commodity.
It's there's implicit prices inside the system. Yeah, it's implicit prices. That actually prices aren't explicitly modeled because I'm doing a purely monetary model rather than a production model. But I've got modeling the cash flows involved, implicitly also modeling the quantities. It's a monetary model. Okay, so let's run it. And what you see is there's the level of debt rising over time. No change in the money stock because you're just shuffling who's got the money. And if I look down here, you see GDP is flatlining. There's a debt to GDP ratio. You can just see down the bottom there slowly rising. Now, these are the control rates over here to change how fast lending occurs. And what I've got, there's number 7 there, says effectively lending doubles every 7 years. And repayment takes every 9 years. So if I say let's lend more rapidly, so rather than 7 years, it's 5 years, notice the debt ratio is now rising. And notice there was a bit of a blip over here to GDP. And let's say as well as lending happening more rapidly, people repay more slowly. So you've got people wanting to hang on to money more for a longer period. They've got optimistic expectations about the future. So off goes the debt ratio. You can see debt raising like crazy. A little blip on GDP over here. Not much, but it does change things a bit. So the debt ratio is going through the roof. The debt ratio you can just sort of see down here, but you can get an idea how much higher the debt is now than the money supply. And then let's have a slump. So suddenly people want to repay debt, they want to get out of debt. So down goes the level of debt, and let's say lending is much slower as well, it takes many more years to double. Notice there's a change in GDP. In fact, by reducing the amount of debt, the overall level of the GDP actually rose, but not a lot. So generally speaking, if this model was accurate, go back to the initial default values there, you could ignore the banking sector. Okay? But I'm looking at all this dynamics of debt, I'm not getting much of an impact. So it's a reason to ignore the sector. But a little bit, and I'll just, what I do in the PowerPoint is show that particular slide. I'll just go and bring it in here. Oh, by the way, you notice debt didn't turn up in the table of the bank. Simple reason, the debt is not an asset of the banking sector, because the consumer sector is linked to the investment sector. I've got to record debt somewhere else. So I record D for debt as an asset of the consumer sector. And that's that little bit there. So lending goes from the consumer, it reduces the amount of money the consumer sector's got in its bank account, but it increases the asset it has of the debt the investment sector owes to it. So,
Sorry to interrupt you. Like, could you continue on the slide?
okay.
Are you holding the debt right to the concept of the
No, I'm leaving it out, but if I had it inside there, it would be changing.
It will be changing.
It would be changing. If I put the whole model, you'd have relative prices changing as well, but I haven't. I'm just doing a very simple monetary model. The main thing I want to do is just do a structural comparison. See, if I was doing a full model, I'd want to have a physical production system, relative prices, etc., etc. All I want to do is say, let's just leave that in the background and just look at the monetary flows. Looking at the monetary flows, Krugman's right. If the model of loanable funds, as he calls it, is correct, then there's no impact from lending. But let's say something very mystical here. What if banks actually do the lending? That sounds mystical, does it? It's what actually happens, isn't it? Well, let's just go across and change that model. So exactly this model, I'm going to go inside here and say that here's the consumer sector. Again, I hope you can see that on the screen. But there I'm showing the debt as an asset of the consumer sector. Well, it's not. So I'm going to delete it from there. And I'm going to delete lending, which doesn't go to the consumer sector, delete debt repayment, delete interest payments, and yes, there is some intermediation that banks do, but I'm going to get rid of that as well. So I've got rid of all that and come back over to the banking sector and say that the loan is actually an asset of the banking sector. So if I click on the plus column here, I then create another asset for the banking sector. And what assets are available? Well, I've just removed the debt, but it's still shown as a liability of the investment sector. So what Minsky does when I click on this is say, well, here are the operations. So lending, debt repayment, and interest payments all occur to the banking sector now. And all I've got to do is say the interest is actually paid to the bank, not paid to the consumer sector. And let's get rid of that fee from here as well. And I'm also just going to change one more detail here, delete that element there and say that the level of lending is actually based on the current level of lending, a basic exponential growth type equation saying beforehand I had lending based on how much the consumer agent had, now I've got lending based on how much debt's already there in the system. Reset it and run it again. You always have your heart in your mouth when you do this sort of stuff. Did it work? Let's see. Pause and start again. Yes, it is, but it's very slow. Let's just increase the rate of lending there. And notice the amount of money is rising. Okay? And notice also GDP is rising. Let's slow down the rate of repayment. I've got a boom. The lending is creating money and it's also creating demand. What if there's a slowdown, so banks suddenly lend much less and people repay more rapidly? You have a crash. The economy collapses. Let's go back to the initial situation again. That's how different the world is when you take money seriously. And that's the sort of work that post-Keynesians in general do. I'm not far from the only person doing this sort of work in the post-Keynesian field. There's a whole area, what they call stock flow consistent modelling, where people are trying to build monetary models of the economy and so on. I think this is the most sophisticated software that anybody has to do it. But we're now saying money matters. You've got to have a monetary vision of capitalism. So what you've got with the neoclassicals is they're leaving out possibly the most important influence on the level of economic activity. I'm then trying to tell you how to run the economy. So bank lending does matter. And the view that this is what's called endogenous money. And money is created by lending. So when you learn the conventional theory, they'll tell you this, what they call the money multiplier model and what they call fractional reserve banking, which basically says you deposit a certain amount of money in a bank hangs onto some of it, lends out most of it, that gets deposited to somebody else who then another bank hangs on to a bit of it, lends out most. It's technically impossible. And of all people, of all organisations, the Bank of England just recently published a major paper saying that the conventional view is wrong, the textbook view is wrong. Now, Krugman read that and said, well, it doesn't change. I agree with it, doesn't change anything, I think, which is ridiculous, okay? But they're ignoring this model. Technically, it can't happen. You can't lend reserves in that way. Banks don't do that. If they did, you'd go to get your you go shopping with your $1,000 and find you only had $100 in your account. Technically, it doesn't work at all. It's not how banks operate in any way at all. But the more important thing is it has huge impacts on the macroeconomy to look at how banks actually do lend. And of course, we also have this attitude that if you lend something to somebody and they don't return it, they've stolen from you. But in this case, banks create money out of nothing in that sense. It's just a bank operation, an accounting operation to do it. So they're not making a sacrifice to create a loan. In fact, they profit because having created the debt, they generate the income out of it. And that means banks have got a strong incentive to create as much debt as they can, and talking us into housing bubbles is a good way to do it, or stock market bubbles. So I think you can't trust banks to control how much lending could occur. And there's a wonderful little example of this, the point about creation of money being essentially costless compared to producing a real physical commodity. This happened about a year or two ago now. A New Zealand petrol station owner applied for an overdraft with Westpac, which is one of Australia's major banks. They run the banking sector in New Zealand as well. And he got the overdraft. That's him in the court case, because Westpac made a clerical error. Rather than giving him an overdraft of $100,000, they gave him an overdraft of $10 million. He saw that he had $10 million access, withdrew 3 and banged off to China. They managed to get him back. Now, how did the bank actually create $10 million when it wanted to create $100,000? Well, is anybody here worked in a bank? Anybody? Okay, a couple, okay. Bank keyboards have got a 00. Okay, you make a loan to somebody, you press 100,000, decimal point, 00. The bank clerk didn't press the decimal point. And by not pressing the decimal point, one less keystroke, so less energy, less work, okay, created 100 times as much money. You try doing that with a physical commodity. Okay, so it's very, very different to a physical commodity. We can't think about it in that sense. And that's, again, part of the reason why booms and busts can be created out of the financial system and why it does have to be treated differently to other parts of the economy. There is something mystical about being able to create 100 times as much of something by doing one less thing. Okay? So Hyman Minsky, as I said, is the guy who gave us the most coherent vision of this, and he argued that there's a conventional view, and this is, as you can see from Krugman's thinking, that it's possible to have a financial system where there are no disturbances from the financial system. And that it's a task of working out monetary theory to work out what that financial system should be. And he said his alternative view, which he called unreconstructed Keynesian, and by that he means that Keynes was reinterpreted as a conventional economist, largely by a guy called Paul Samuelson. So when you're told this is Keynesian, when you're doing a macro course, strike out the word Keynes and write Samuelson. And then you've got the actual person who created 99% of what you'll get taught in a standard mainstream course. Now, he said the alternative view is that capitalism is inherently flawed, subject to booms and depressions, and that's due to characteristics that it must possess. Okay, not something that's a flaw that you can remove, an imperfection. He's saying it has to have these characteristics to actually be capitalism. And then what it generates is accelerating desire to invest and a way to finance that investment. By the way, this is not necessarily a critique of capitalism. It's just saying this is its nature. And one of the essential things about capitalism is those booms and busts can give us the technological development we see over time that the socialist systems did not produce. So Minsky comes from a background that says that instability is not necessarily a bad thing, particularly when it means you get people like Tesla being financed, though a large part of their financing came from the government, but innovation being financed by capitalism, or the potential for innovation, also comes out of the same source. So instability in its own right is not a bad thing. It's when it becomes financial instability that causes a crisis. That's another story. So Minsky said, how do we analyse this? How do we analyse this behaviour of a genuinely financial system? And notice he says the starting point for analysing the relation between debt and income. So he's directly saying there's a relationship between debt and income. He said to take an economy with a cyclical path, so your model must be cyclical. It can't be an equilibrium model that doesn't have cycles, that's now doing well. And he said, as the period over which it does well lengthens, two things become evident in boardrooms. Now notice that again, that's talking about financial corporations, not barter somewhere in a New Guinea highland, which is what I think conventional theory is really appropriate for, but the sort of stuff you see happening in New York and Wall Street and London, boardrooms, shareholders, etc., said it becomes obvious to those institutions that are running large corporations that existing debts are easily repaid, and units that were heavily in debt prospered. It pays to lever. So therefore, given that fact that as you get further away from a crisis, people begin to believe that leverage is a good thing, having been scared of it during the crisis itself, so that stable growth is inconsistent with how investment is financed. And this is a classic phrase, the fundamental instability of a capitalist economy is upward. Now again, you'll find lots of critics of capitalism coming out of largely a Marxian tradition, other traditions as well, but they've often said capitalism tends to go into depression and slumps, and there's a thing called the tendency of the rate of profit to fall, which is a Marxian argument that I think is completely wrong. But nonetheless, that's the sort of tendency to go down is the way that a lot of people criticise capitalism. Minsky said instead its tendency to go up and be debt financed and then have a bubble which crashes with too much debt. And he said the tendency to transform doing well into a speculative investment boom is the basic instability of a capitalist economy. So that's the vision that he's got. And what I did in my PhD, and I've since done a few more things on it, is I took that verbal model and made it into a mathematical one, starting from a cyclical model. And the cyclical model itself is really quite simple. You start from saying the amount of capital you have determines your output. And this is all first order stuff. You can have flexibility between level of capital and level of output, but the basic model Goodwin had was just a strict sort of numerical relationship between the amount of capital and the amount of output. The amount of output determines how many workers you need to hire. How many workers you hire determines the rate of change of wages. That's the basic, what's called Phillips curve relationship that virtually every economic theory has. Wages then determine profits because you already know output, so you subtract wages from output and you've got profit. Profit determines investment, and an investment determines the rate of change of capital. Now notice I've got two rates of change there. Rate of change of wages, rate of change of capital. So there's two rates of change variables interacting with each other, and that gives you cyclical growth. And I'll build a very simple version of it here. I think I've got it running, I'm not sure. Maybe I haven't got that one running. I'll just keep on going with the demonstration here. What you get with that model is cycles. That this is the, can I run it from here? I don't think I actually enabled that. No, I can't. I'll fix it up later. Well, that's the level of the wage rate, and that's the level of employment. And they fluctuate. If you map them against each other, that's how they behave. So constant cycles. And often conventional economists look at this and say, oh, the economy is not that regular. Well, of course it's not. This is too simple a model. You add more details to it and then you get that complex behaviour. So what I did was say, well, that's a nice starting point, but it's a bit unrealistic because what he had was that capitalists invest all their profits. Okay? Well, they don't. They invest more than their profits during a boom and less than their profits during a slump, if they're lucky. So therefore means how do you finance that? You finance it by borrowing money. Okay, and that's why the endogenous creation of money is so important. So, and then banks, of course, because they've lent you money, they charge interest on that, so you've got to have banks inside there as well. So I put those that elements together, and I'll show you the behaviour in a second, but it changed the nature of those cycles in several ways. First of all, you got much more complex cycles. You could have a head towards an equilibrium, a good one, or you could head towards total collapse. It depended upon the initial conditions and parameters. And this idea of stability leading to instability you'll see in a moment. There was a rising, when the crisis occurred, there was a rising level of debt to GDP. And as that happened, things are for a while, if you were just looking at employment and inflation, things got better. Less volatility in employment, less volatility in inflation, and falling level of inflation. And then there was a breakdown. And also, inequality rose. We've also seen that. So all that sort of stuff turned up in the model. So I think I've got that one running here. Let's see if I can find it. Okay, I shouldn't have. How do I? Okay, stop it there. Right. So that's the same model I've shown you a moment ago with those extra complications added in there. And if I simulate this model, you'll see that there are cycles in employment. Notice how they've got smaller. And notice with the black line here is wages share of output. That's my proxy for inflation in this system. So workers' share of output's falling. If you map the two against each other, rather than getting those cycles I showed you beforehand, you get that funnel forming. And if you thought in equilibrium terms, you think it was converging towards equilibrium, but look what's happening. Cycles start to get larger on the other side. And over here, you've got a debt level which is rising in a series of humps. They're fairly tiny at this, as you pass through the funnel. They get bigger on the other side. Ultimately, you get the whole system crashing. Now, I built that model in 1992. Which was before what was called the Great Moderation began. And this is not a prediction of Minsky's model. This is one of the reasons that mathematical reasoning and complex systems thinking is a contribution to what we can do in economics. So I'm very pro-mathematics if it's the right sort of mathematics, which is dynamics, complex systems, and so on, because this is an insight that wasn't in Minsky. And when I saw it, I was so surprised by it that I decided to finish my article with a rhetorical flourish. I'll just, that's what you've seen me running there. So when I finished the article, I wrote this, nice piece of flowery language at the end of the paper saying from the perspective of theory and policy, this requires us to go beyond the habit that Keynes described so well of the excessive reliance upon a stable past as a guide to the future. And here comes the rhetorical flourish. The chaotic dynamics explored in this paper should warn us against accepting a period of relative tranquility in the capitalist economy as anything other than a lull before the storm. I've got a bit of a theatrical background, so, theatrical way of finishing it. Well, guess what happened? Take a look at the post-1992, actually for the post-1980. We experienced this declining levels of volatility in employment and inflation. This is looking back to 1980. The blue line is inflation, the red line is unemployment. Notice the decline in both, and lower level when you have a recession. Of course, recession here, recession here, recession here. Lower peak levels. And looking just at unemployment and inflation and ignoring debt, of course, as just explained why they ignore debt. Neoclassicals thought this was wonderful. There's an expression, have you heard of what's called the end of history? Okay, Fukuyama. I think that's probably one of the most embarrassing papers in history ever. But anyway, the economists outdid him by a huge extent. This is Robert Lucas. Heard that name? Okay, one of the Nobel Prize winners, one of the guys who founded the conventional approach to business cycles. And speaking at the end of 2003, when he was president of the American Economic Association, he gave this speech saying that macroeconomics was born in the 1940s. Interesting, Keynes had done his work in the 1930s. He said as part of the intellectual response to the Great Depression. He said it referred to the knowledge we hope would prevent another experience like this. And here he is in 2003, triumphantly saying, we have succeeded. The central problem of preventing depression has been solved for all practical purposes and solved for many decades. until the one we're in now. Bernanke was just as bad, writing in 2004, looking back and saying, what have we learned since 1979, the last major crisis? He said, as it turned out, the low inflation era has seen improvements in economic growth, reduction in volatility, a phenomenon labelled as the Great Moderation. Recessions are milder, volatility's declined, etc. He said there's many arguments to where it come from, but he thinks improved control of inflation, which really says, pat myself on the back, monetary policy, which I've been partly in charge of, is why the economy is so much better. Notice this welcome change in the economy. Now, this is the OECD, and June 2007, by the way, is roughly 2 months before the crisis began. The date that people use as the sort of historic event that signalled a crisis was well and truly on the way was in August 9, I think it was, so just a couple of months after this, when BNP, Banque Nationale de Paris, shut down 3 funds it had which were exposed to the subprime market in America because they said they had no way of valuing these funds. And that was the beginning of the shocks that led to the realisation we're in something serious here. So writing 2 months before that, the OECD, using the technology which conventional economists use now, which is what they call dynamic stochastic general equilibrium models, DSGE. In my opinion, they're neither dynamic nor general. Okay, they're stochastic equilibrium models. But he said we weren't going to have a slowdown according to this model. We'll get a smooth rebalancing with Europe taking over the baton from the United States and driving OECD growth. And the current situation is in many ways better than we've experienced in years. He said, our central forecast remains quite benign. Now imagine you're a politician reading this stuff. You think you can basically go on holiday in Majorca for the next 3 years and take credit for good conditions. Okay? 2 months later, you've got to cancel your holiday. They said, sustained growth in OECD countries will be underpinned by strong job creation and falling unemployment. Bang. Well, something went wrong, and this is the reason why. This is the ratio of private debt to GDP in America. So if you ignore that trend, don't think it matters, you see good times ahead. But that's an essential part of Minsky's vision and an essential part of the mathematical model that I developed. And that's when I saw those numbers in end of 2005, I thought, holy hell, something big's, we're possibly in for the biggest crisis ever, because this is the biggest level of debt since both the Second World War. Somebody has to raise the alarm, and that's why I started making all the media noise that I've made ever since. And my argument was the crisis would begin when the rate of growth of debt slowed down, because that rate of change of debt is the rate of creation of new demand by the monetary system. Notice the date, the crisis there, that's August 9, 2007. And there's the trend, particularly sharp in America, pardon me, for the rate of change of debt to decline, and it didn't have to go negative, just slowing down was enough. But then in the peak of the crisis, the level of debt was falling by about 4% of GDP per annum in America. And then, of course, rather than going down, unemployment and inflation exploded. So that's suddenly, after the crisis, up goes unemployment. And by the way, if they were using the same way of measuring unemployment in 2008 that they're using back in 1980, the unemployment rate would be 2 or 3% higher than it shows there. So if I wanted to compare this point, it would actually be up here if I use the definition used back here. So it looks like it's lower than the 1980s, but in fact it was substantially higher. Americans had all sorts of ways they redefined unemployment. In fact, one way to reduce unemployment in America is to have people be unemployed for more than a year, because they drop them off the lists. They fall off year 3 and go into year 6. Starving also helps. Notice we had deflation. For a while, price level was falling by 2% per annum. And other relationships I look at as well. According to conventional theory, those two lines should be unrelated to each other. That's the level of unemployment and the change in debt. Now they're negatively related. If I looked at the level of employment and the change in debt, there'd be a positive correlation. But I get a correlation of minus 0.9 between those two factors over 25 years. And you would think conventional economists would want to investigate that, wouldn't you? Empirical phenomena that's not supposed to be there. I still haven't had a conventional economist take a look at it. This is looking at having had a relationship between the change of debt and the level of employment, The second thing is looking at the acceleration of debt and change in employment. And the correlation there is again stunning. Okay. Virtually the same level, which is, I didn't expect that. The one reason I didn't empirically investigate this until after an economist working in an English bank, I've forgotten the name, but a guy called Biggs and Mayer and Peck did a more neoclassical explanation as to why debt matters and developed a thing they called the credit impulse. And they did this empirical work, and I was stunned because a bit of cowardice on my part. I didn't think empirical data would actually support this, so I didn't try investigating it. But they did. They found this correlation. I then checked it, and it applies to virtually every country on the planet, a couple of exceptions. There's enormous correlation between the acceleration of debt and change in unemployment, and also asset prices. This is looking at the level of the real house price in America and the change in mortgage debt. So again, we've got change in debt driving not just real economic activity, but also asset markets, including the share market. And the same thing, there's a positive correlation now. The higher the change in mortgage debt, the higher the rate of change of the level of house prices. But here's the correlation between the acceleration of mortgage debt and the change in house prices. And that correlation is also quite high, 0.8. So it's a very profoundly, it's a logical argument, it's got a strong empirical backing to it, and it means that the conventional view of macroeconomics just has to be thrown out the window. And certainly saying this crisis couldn't be seen coming is a logical error. Okay? It couldn't be seen coming using the wrong theory. I make the comparison often that conventional economic theory is a bit like Ptolemy's theory of astronomy. You know Ptolemy's theory? The idea of the Earth being the centre of the universe and the planets and the circling us, okay? Well, one thing that theory couldn't explain is comets, because the comets couldn't be coming from the sky because the sky was perfect. So according to that theory, comets were an atmospheric phenomenon. And of course you couldn't predict them because it's just something happening in the atmosphere. So everything was imperfect was on Earth. The heavens were perfect and unchanging, perfect crystalline spheres. So the explanation for comets was something atmospheric. Well, therefore you can't predict them. But of course, according to Copernicus's theory, they were an object that was circling the sun. Not circling, going through ellipses and all sorts of shapes like that. So you can predict it. So it's the wrong theory, you can't predict it, it's unpredictable. It's not the phenomenon that can't be predicted, it's the wrong theory being used. So that's the background of me seeing the crisis coming and saying why we're going to have a really bad one. And of course government rescue was a major part of why it didn't get to be as severe as the Great Depression in this country. Government response being the wrong response, being austerity, is why it's worse than the Great Depression in Europe. And truly it is worse than the Great Depression. Okay? The severity of the crisis, length it's lasted for, the European Union with its focus upon austerity, which is similar to what the Tories are doing here, entirely the wrong policy. But is it over? We're not going to see it again? Well, it comes down to the level of debt. This is looking over the very long term, both private debt and public debt, government debt. And all politicians and conventional economists obsess about the level of government debt. Look which one is bigger. Okay. And in fact, government debt counterbalances downturns. Government debt tends to rise when private debt falls. It's a counterbalancing effect. But over the whole time, what you can see is a rising trend, the level of private debt, amid systemic crises. And the level of deleveraging that has occurred in America is quite trivial. And similar in England too. So what's now going on is another boom is taking place. But it's a boom starting from a level of debt that's never been experienced before. The last time we had a boom in America began in the 1990s at about 90% of GDP. The boom is now beginning at 160% of GDP. And one of the people that I work with on this is an American banker, the guy who established America's two major credit card companies, sold them both, retired. He won't tell me how much he's worth. I'm guessing it's anywhere between $500 million and a couple of $1 billion. Become a philanthropist, He's always had a philanthropic and artistic side to him. And he's published a book recently where it's called The Coming Crisis, why it's going to happen and what to do to avoid it. And he's done a typical banker's piece of work of looking at the numbers and looking across about 30 economic crises over the last 100 years. He said there are two characteristics that determine that a crisis is going to happen. One is that the ratio of private debt to GDP is 150% or greater. And look where America's starting at 160%. And that ratio rises by 18% or more over 5 years. Now, that by 18%, it means going, say, from 160 to 178%. Now, if America did that, if it went back to 178% of debt, it would just get back to where it is, where it peaked in back in the current crisis. So all America's got to do on Richard's, by the way, I always hold up on saying his name because his last name is vague. He ain't vague. He's a very precise man. Richard Vague's book, I highly recommend you to get and have a good read of, a good empirical look at where crises come from. And his argument is that all you need is for this to trend back over the next 5 years. There'll be another crisis in America. And according to his empirical measure, China is already in crisis situations on a grand scale. So he's expecting a crisis in China in the next 2 years, again driven by the same sorts of dynamics as here. So I think it will happen again. We haven't delevered anywhere near as much as we did in the Great Depression. We delevered in a very painful way, obviously. It involved the Second World War. And I don't think we're going to see 15 years between this beginning of this boom and its ending in much the same story as last time. And I hope that that will be enough of a crisis to make conventional economists think that maybe they've got something wrong in their theories. Now, I'm going to just quickly take a bit of a... I should take a break, I think, because I think I've hit you with a fair bit of stuff here, haven't I? I've got another bit of an argument as well, and I won't go through the whole thing. I was giving a lecture. I'd say, let's head out and go to the pub now, which might be a good idea, because what I'm going to do is go to a slightly different topic, and I won't go too far into it. I've got a lot of slides here, and what I'll do is I'll leave the slides with Severin to pass around. And this comes from the lectures I've given, which I think you can find on YouTube as well. But often, when I've given presentations like this, I've often had a neoclassical economist, the audience, say, yeah, well, there's lots of problems with the macro, but micro is pretty good. Bullshit. Pardon me, but bullshit. Micro is worse than macro. Micro is based on so many wrong a priori notions. And I want to just cover very, very quickly one of them because it's superficially appealing. It seems quite straightforward. And I'll give a little anecdote from the conference I was at in New York. There's a progressive neoliberal economist called Deirdre McCloskey who came along to the discussion and gave a very good talk to the students and encouraging the rethinking movement that you guys are part of as well. And Deirdre, when I was saying that, I said, I think I used the word crap rather than bullshit. And she said, oh, come on, Steve, you've got to admit that when the price of coffee rises, demand for it will fall. Now, often a conventional economist will use some argument like that takes me so much by surprise because it's so transparently wrong that I don't know what to say. And I didn't actually reply to Deirdre, but I can say, the sun's going to come up in the morning. That truth's told me is right. The empirical reality that, yes, normally if price of something increases, demand will fall, doesn't justify a bad theory of why it happens. Because exactly the same rationale was used by Ptolemaic astronomers to say, look, obviously we're right, the sun rises. Every morning it comes up. Okay? Now, of course, what we know is going on is the Earth is rotating. Okay? It's a change of perspective. But you can have a bad theory, which you can explain by an empirical regularity, but you can't. A bad theory can't be justified by empirical regularity. In fact, when you look at it, the conventional theory doesn't even explain that very phenomenon of demand for something in the market falling as price rises. And I'll give you a quick look at this. You know the expression of an on goal? Plenty of soccer players here. Have you seen this one on YouTube? It's absolutely wonderful. Watch this poor guy. Can you? the sort of thing you want to do? Well, there was a brilliant own goal by neoclassical economists because, and I'll explain that rather than going through the whole presentation, because it's too much. I think we need to take a break after this and go and chat socially about it. But what they were trying to do is say that you start from the idea of consumers being what they call rational utility maximizers. And then from that, you derive a demand curve. And the demand curve, you then say, gives you the market demand curve. And this is all stuff, I'll cover a bit of it technically because I know, I want to give you a background to be able to read it yourself later. One of the criticisms of conventional theory of demand, consumer demand, was that these things were called indifference curves that were supposed to be an important part of how people behave, but you can't actually observe them. Has anybody here heard of indifference curves? Who hasn't? Just get an idea. Okay. There's supposed to be a way of mapping, a bit like weather isoquants. You know, if you go and see the weather map and you see these lines that show the weather pattern, it's showing you lines of equal barometric pressure. Well, the idea of indifference curves was similar. It's saying we can work out combinations of commodities that give a consumer the same level of utility. So if you gave them a choice between one combination, which might involve, say, lots of bananas and very few biscuits, that would be the same level of satisfaction of a lot of biscuits and very few bananas. I use nonsense examples, by the way, because I think the theory is nonsense, but this idea that you can join these 2 points together using an indifference curve. And the objection was made by, these were invented by Paul Samuelson, so again the Samuelson name comes up, and he was told by many people, well, you can't observe these things. People don't actually have indifference curves. So you can actually observe where barometric pressure is the same over a country. That's what the measuring stations give us that data we see on the weather maps. That's actually an empirical thing. But you can't ask somebody to show me your indifference curves. You know, it just doesn't happen. Well, he said, well, we can't show them, but we can work out what they are by asking people questions about what they'd buy. So he had these things he called axioms of revealed preference. This is not taught anymore in undergraduate courses. It's taught in some masters and so on. And it said, well, take two commodity bundles, A and B. You know, lots of biscuits, very few bananas, lots of bananas, very few biscuits. You can ask somebody whether they prefer that A to B, B to A, or they couldn't care which one they get. Well, that's called, and it says, given any combination, you can work out whether you prefer or not prefer. Does that sound reasonable to you? Given two combinations, you can work out which one you prefer? Okay. Transitivity means if you prefer bundle A to bundle B, well, think about it, shopping trolley. Imagine you've got shopping trolleys, and I'll put a certain amount of different commodities in two shopping trolleys. So there's shopping trolley A, shopping trolley B. You look at it, and there's different amounts of commodities in both, and you can say, I prefer A to B. And if you prefer A to B, and you prefer B to C, you're going to prefer A to C, aren't you? That's transitivity. And there's a slightly more non-satiation. So you could prefer A to B. If you couldn't care about A versus B, and I throw an extra Mars bar into A, you're going to prefer A because you've got more stuff in it. And the final one, convexity, which is basically talking about the amount of utility declining as you get more of each individual item. So with those rules, he said you can then represent preferences using this sort of surface. And there's these X and Y and Z and W are levels of indifference. So anything along the X curve, you don't care which amount you get, but you prefer to be on X to W and you prefer to be Y and Z to the others. So these are the indifference curves. And there's B and A, you couldn't care which one you get. If you look at Z, then you prefer all the Zs to the Ys. So Z1's preferred to Y2, even though there's many more bananas in Y2 than there are in Z1. You prefer Z1 because the extra biscuits more than compensate. And more's always better. So any point P, any point I could put in the Q or above, you're going to prefer a point Q. And having had this argument that you couldn't actually observe it, he said, well, using revealed preference, we can work out what it is. Because we can actually infer what people do and then drive their curves backwards, which is clever. Think about it. Saying, hey, let's give people a range of choices, work out what their choices are, and then we can say, here's your indifference curves. Now, the intriguing thing is, I'll just jump over this one rapidly. This is the basic idea of saying how you can do it. There's more conferred to less, so anything above A you've got to prefer. After a range of choices, you can map through this whole thing and work out what your choices are. So you can go through this whole laborious procedure and tell somebody what their indifference curves are, which is really cool. Okay? So there we derive your indifference curves for this particular person. And then having done that, I'm sort of, can you cope with me going through a bit more of this stuff? Keep going? Okay. What you then do is work out a person's indifference map overall. So I'm looking at bananas now versus all other goods. And they've got all these curves here, so I've worked out what those curves are. And then we say, well, here's a few relative prices. I'm going to change the price of bananas. And as I make them cheaper, you buy more. And notice by changing the price of bananas, I don't change your income. Important point. Well, having done that, I can now drop down from those points of choice and make a map that shows your demand curve. Map them across. There's the Q1s, there are the prices. And there's your demand curve. Hey presto. But that's an individual demand curve. It's not a market demand curve. But it's called the law of demand, that consumption of a good will rise as its price falls. And this is the neoclassical explanation for an empirical regularity that, generally speaking, for most commodities, as the price falls, people demand more of it. It doesn't apply to Prada handbags and stuff like that, or Lamborghini cars, but it applies to a majority of products. But there are some that actually have consumption falling as the price falls. And they're who's heard of a Giffen good? Yeah. There's a good dispute as to whether Giffen actually invented anything like this, but the argument was that that explains the potato famine in Ireland, because as potatoes got more expensive, people consumed more of them because that's all they could afford to buy. Now, that means there's an income effect going on. As the price of potatoes rose, your income fell, so all you could afford to eat was more potatoes. And that can overwhelm the substitution effect, that as the price gets more expensive, you should consume less potatoes. So to get rid of that, a guy called Hicks, that's another name. I have more time for John Hicks than I have for Paul Samuelson, because Hicks was willing to admit, my God, I made a huge mistake, called the ISLM curve. He wrote a paper by, if anybody wants to read this and get a bit of technical background, Hicks invented the ISLM curve before Keynes wrote the general theory, then put the ISLM curve across as a summary of the general theory, and Krugman is quite right, you can find a lot of ISLM sort of stuff in the general theory, but in 1980-81, Hicks disowned the ISLM model in a paper called ISLM An Explanation, which I say is better titled ISLM An Apology. But anyway, working in demand, he said, well, we can actually cope with this, we can get rid of the income effect if we do what he called a substitution trick, that because we know that if you make a good cheaper, you actually increase people's incomes. But we want to say, well, what will they consume given a constant income? And you say, well, constant income really comes down to being on the same indifference curve. So if we take an initial budget line and then see what combination somebody chooses, like here, so that's the amount the person chooses, then you get a cheaper price, and the income doesn't change. You move up to a higher level, but there's both a cheaper price and a substitution effect going on here. So he said, what if we want to get rid of the income effect? We simply take a parallel line back from the new one and put it touching the old indifference curve. And that's just the pure substitution effect. And they said, if you do that, that necessarily slopes downwards. That's the little trick going on there. Again, I'm going through this very, very rapidly. I would never go this fast in a genuine lecture, unless I wanted to be strung up by you guys. But can you cope with it at this speed at the moment? Okay. Because it does get a bit boring, doesn't it? And I think this is actually a major part of why neoclassical economics works. It bores the pants off people who've got a bit of soul, and they drop out of economics degrees. Now, I find it gets interesting because I can prove this is all wrong in two ways. The first is, and I'm going to leap over this and come back to it, what you get in all that is an explanation for a single individual's demand curve. How do you get the market demand curve? So it's glossed over. I think I challenge anybody to find it in a textbook. The one textbook I know it's mentioned in is Samuelson's textbook. And you should see how Samuelson justifies it in his academic papers. But they just jump over it. They don't actually tell you that you've got to go from the individual to the aggregate. But looking back at the individual, the idea that you can actually reveal this to somebody in this really clever trick was actually taken to heart by a German researcher called Sippel back in the late 1990s. And he thought he'd do this. I don't know for sure, but I'd love to meet him. I've got to, one of these days, see if I can find him in Germany one day. Might have to you might help me out there, track him down. But I think what he did was he thought he'd show his students how this stuff actually had real substance to it, because he did a trial. He had published a paper in the Economic Journal where he did a study with 12 students. Now, 12 is about the size of a tutorial. Okay? Then he did a second study with 30. Why did he do a second study? Because the first study, 95% of his students contradicted the theory. And then the second lot did the same thing again. It was a very careful experiment. And there were plenty of experiments beforehand trying to test this theory. But, I mean, you've got to laugh. Household expenditure surveys were done, but of course that doesn't tell you anything about this theory, because your taste can change over time. You've got to somehow freeze time, just take a particular point. So these ones don't make any sense. And I mean, I love this. They did a surveys of inmates in a psychiatric hospital. Yeah, I know. What are you trying to prove? Trying to be rational? They had a shop where they could vary the prices at will with a certain sort of token that they got to shop, and they saw what their behaviour was. I mean, give me a break. It's been done for rats and pigeons. Rats and pigeons have an easier time doing it, and there's a simple explanation as to why. But Sippel used university students as his rats, and he gave them a set of choices of 8 commodities. He gave them a budget constraint, which he varied each time in a range of experiments, and 8 commodities to choose from. And they were really sensibly chosen commodities, because they're things like watching a video clip for a certain number of minutes. This is, if you spent all your money, you could watch 30 to 60 minutes worth. Playing a computer game, reading a magazine, having a Coke, etc., etc. Sort of stuff you do, you know, party behaviour or chilling out after studying. And this condition was, not only did you have to choose what you preferred, you got at random one of the 10 bundles that you did choose in each of the 10 cycles he went through. So whatever you chose, you actually got to consume after the experiment was over. And he gave them unlimited time to choose, but most of them finished in about 40 minutes for the whole 10 instances. And he then said that there were no doubt they were trying to choose what they liked the most. They really were carefully working it out. They'd consider something, cross it out, put something else in later, etc., etc. And they often said they really hoped they got a particular one of the bundles too. There'll be some particular one of the 10 that they were chosen given the price combinations and budget constraints. What was going on behind all of these were testing these various what are called axioms of revealed preference. So there's one, they're called warp, SARP and GARP. And the weak axiom is that if you prefer A to B, you'll never prefer B to A. That's a shopping trolley example. The strong axiom is that if you prefer A to B and B to C, then you never prefer C to A. That's the transitivity one. And a more complicated one is called the generalized axiom, and that talks about the cost what you're going to lose in terms of making a bad choice. It takes the prices into account as well. So he tested all of those in those various examples. And I'll jump over. This is an example. If you're given those A and B, and you can, like in that particular case, you can choose A or B. Of course, they're discrete amounts, so you couldn't necessarily get a smooth curve here. Well, if you choose A over B, because A is on a higher indifference curve, if you can afford both, you should always choose A, no matter what the relative prices are in that combination. Okay? That sort of thing. Otherwise, you're being irrational, according to the theory. And of course, you want to prove you're rational, again, according to the theory. So you should always choose whatever budget you get. If A and B are two of the choices you face, then you should always prefer A to B, never B to A, that sort of thing. That's how I decided whether people were rational or not. Well, 11 of the 12 were irrational. 5 violating the weakest axiom. Second experiment, 22 of the 30 violated those axioms. And 2/3 violated the GARP test as well. It's a pretty tragically bad attempt to prove the students were rational. Okay. And he kept on trying to interpret it, but he had reached a very, very sensible judgment. It said, we conclude that the evidence for the utility maximisation hypothesis is at best mixed. While there are some who appear to be optimising, the majority are not. Okay? And he then said, we call into question the universality of the maximising principle. You won't see that in your textbook, will you? Very careful attempt to apply it. Now, what are they doing? Are they being irrational? Or is it something about those axioms? It's actually the definition itself that's irrational. And I'll go through the basic assumptions again. You're supposed to obey these various rules. The one none of you objected to, and this is common, completeness. You think you can make a choice. So given any two bundles, you can choose which one you prefer. And that looks really easy on a two-dimensional graph. If I whack this graph up here and say, you know, choose me a couple of combinations, easy. What happens when you've got to choose 100? How many commodities do you reckon are inside an average supermarket? 10,000, roughly speaking, is the average size of a supermarket. You might break it down to about 100 or so different commodity groups, but there's at least 10,000 in a standard supermarket. But here's the bananas and biscuits example again. There's a particular budget line, and there's the amount you're supposed to choose. And then if you put some numbers on it, notice these graphs never have numbers. Take a look in your textbook, you won't see numbers on them. So I thought, well, let's whack some numbers in here. And that's the sort of pattern you might see. There's the between 0 and 9 biscuits and 0 and 9 bananas. Well, that gives you 100 combinations. Now, a lot of them you're going to rule out because they're just too far outside the budget constraint. They may be too expensive or too cheap. But there's at least 9 or 10 there that are within reach of the budget line, so you'd have to think about them. And that means you've got to add up 10 budget sums to see whether you can afford them and make 10 utility comparisons, which you prefer. Pretty simple. What about the third commodity? I've got bananas and biscuits there. What did I chuck in here? Let's see. You've got to add an extra axis in. So you have 10 units of each, and there's 2 commodities. You've got 100 combinations. 3 you've got 1,000. 4 you've got 10,000. How many combinations did simple students face? Now, they were given a smooth amount. They could choose any amount they like at all. But they had 8 commodities to consider. So if you imagine like just discrete combinations, only 5 different combinations, that's 5 raised to the power of 8. Any idea how big that is? It's amazing how people can't do power calculations. It's about 390,000 combinations. We are now talking 390,000 shopping trolleys. Can you pick up which one you prefer? Okay. Well, it gets worse when you start thinking about the real world, because when you go shopping, you're going to have an unbelievable array of choices. So just imagine there's only 100. Forget about the huge complexity of individual item. I think just 100 categories, which you could certainly achieve in a shopping market. Do you buy or not buy one of each category? Well, if you put each of those into a shopping trolley, how many shopping trolleys are you going to fill? And pick the one you like the most. 2 to the 100, I can't even read that out. It actually works out being in verbs. 1 million trillion shopping trolleys. I imagine that it probably covers something like the size of Europe. If you're lucky, probably larger than Europe. Might even be the size of the planet, or bigger than that again. So it's a toy model. Like a whole lot of economic theory, unfortunately. It's a toy model that looks good on paper, but when you extend it to the real world, it just falls over. It can't scale to reality. And what's going on here in computing is called an exponential complexity problem, an EP problem. Because the number of combinations you've got scales exponentially, effectively hyper-exponentially. It's 2 to the n. So 2 choices, 0 on unit, but it's n combinations. You get 2 to the n, and it becomes overwhelming. So even if you imagine that the entire human brain was simply devoted to working out revealed preference, you have 10 to the 11 neurons, which is 100 billion neurons. And if each one of those was able to calculate, like a revealed preference calculation, and you did it as fast as we know the neurons react, which is about 10 to the minus 2 per second calculations per neuron, then to decide how, so it would take you 80,000 billion years, to go shopping. Now, obviously, most of you go inside a supermarket and come out in about half an hour. So you're doing something very, very different to this. You're categorizing, you're reducing complexity. So being rational is not making the ideal combination. It's making possible to leave the shopping centre without starving to death. That's what rational behaviour is. So it's just ridiculous to apply this to human behaviour. And on we go. These are non-computable problems. And there's many, many problems in computing which are non-computable. So the whole issue is, how do you get a decision which is reasonable in a finite time? There's a whole area of computing that's based upon this concept. And all this neoclassical stuff is just nonsense compared to that. And here's a beautiful book from a book called Theory of Natural Computation, which is a lot of computing now is trying to emulate what the brain does, because we have to take the brain as the most sophisticated decision-making entity ever on the planet. So how it behaves is a guide to how computing should itself develop. And here are the laws of computational theory. And I love the sense of irony here. Economics needs more irony. It takes itself far too seriously, and it's wrong to boot. It said if the brain is performing computation, it should obey the laws of computational theory. And so these come from two areas, computability and complexity. And paraphrasing them, one, you cannot compute nearly all the things you wish to compute. Secondly, the things you can compute are too expensive to compute. So you can't do optimizing in general. It's a naive notion of what can be done by any processing system. So the whole idea of working from optimizing behavior is itself flawed. So goodbye indifference curves, goodbye revealed preference. None of this can describe real-world behavior. And what is really rational is making a sensible decision that sort of satisfies your needs in finite time, which is where habit, culture, I mean, I've never bought haggis in my life, okay? You'd have to get me very drunk to give it a try. So habit is, rather than being irrational, habit lets you walk out of the supermarket before you starve to death. You go buy the same stuff each time. And marketing is trying to change those habits ever so slightly. Okay? So that's the sort of approach we should take if we look at this area at all. So it doesn't work at all. But let's just pretend it did. I'm going to go through the whole lecture, by the way. You guys are really tolerant. Thank you. Let's just pretend it does work. Okay, we know it doesn't now. This is what I do, by the way, in debunking economics. I'll go through something like this, show why it's wrong, and then go on to say, well, even if it's right, let's see how it works and we go further on. So let's assume it does work. How do you get from a single consumer to a market demand curve? This is the own goal I was talking about beforehand. So you want to go from that. Can you get a downward sloping market demand curve, which is the only thing you'll see in a textbook? Well, the key assumption in deriving the one you get for the individual is that changing relative prices doesn't change your income. Now, if I change the price of bananas, it's not going to affect the income of anybody inside this room. Unless you come from a really exotic part of the world, you've got a very strange climate in part of Scotland that I wasn't aware of. But you can't assume that in a general model. In general, when you change prices, you're going to change incomes, because prices determine incomes. They're part of the function that is going to give you an income level. So doing that presumes changing doesn't change incomes. But when you take it into account and say, well, it does, then that pivot point up here is going to move. And I'll go through this quickly with a bit of an example. But when you do it, when you then start deriving that, attempt to derive that curve, the pivot point switches. So each time you do it, you move the rotation point, and that has a huge impact. I'll show you this very quickly. Now, a set of very skilled neoclassical mathematical economists set themselves that problem of working out under what conditions does a market demand curve have the same properties we've shown for an individual. And the answer was none. Okay? It's called the Sonnenschein-Mantel-de-Breuer conditions. And rather than finding this necessary downward slope, the proof that Sonnenschein states probably most clearly, every polynomial is an excess demand function for some specified commodity in an n commodity economy. Now, a polynomial is a curve you can draw by holding a paper and finger on the page, never going back and causing a loop, and never getting the same value above the x-axis. But anything else that you do is a legitimate demand curve. You find that in one of your textbooks. This is part of the literature. So any shape at all can come out of that demand curve. And to give you a quick illustration as to why, here's the idea of adding up Robinson Crusoe and Man Friday to work out a demand curve for the market. You're getting that sort of result. Now, what was going on here, in my opinion, speaking mathematically, was proof by contradiction. Have you heard of that concept at all? Good. Okay. The idea, if you want to prove that the square root of 2 is an irrational number, you start assuming it's rational and then work through and find that you get a contradiction in your own logic. And this is what I think actually happened here. So you assume market demand curves do obey the law of demand. You derive conditions under which it's true, and you contradict those assumptions. And the basic assumptions that, again, I'll jump over this very quickly, the reasons of time and the fact you guys are going to desperately need a drink after this, I certainly will, is that to have different individuals, they have to have different tastes. So you can't have the same utility function for two people. Secondly, commodities have to differ. And one way they differ, essential way they differ, is you will have one's going to be a luxury or one's going to be a necessity. Okay? You have to change the ratio in which you consume things as you get wealthier. You will not have exactly the same ratio of toilet paper to Lamborghinis in your expenditure list as you get richer. Okay? But what actually comes out of this theory is, first of all, we have to assume we all have the same tastes, and secondly, we buy Lamborghinis and toilet paper in precisely the same ratio as our income rises. And they then call the special conditions under which you can get a market demand curve that's the same as an individual demand curve. It's proof by contradiction that you can't get a market demand curve that slopes downwards. So this is why I said, back with Deirdre's comment earlier, the empirical phenomenon is not explained by the theory. Neoclassical economics does not have an explanation for the empirical regularity they use to support their own theory. So I'll just take, I'm going to jump over this bit here, and notice that whole thing is there about this particular point, the pivot point doesn't change. Okay, to do that operation I showed you earlier, that point can't move. And then also, you can compensate to get that, downward sloping Hicksian curve. You can compensate for any income change. Okay, you can do that little maneuver I showed you earlier, and therefore you get the downward sloping Hicksian compensated demand curve. But what was proven by this very sophisticated mathematics is that it didn't apply when you had more than one person. So my little example is Robinson Crusoe and Man Friday, and they've got different income sources and different tastes. If they don't have different income and both different income sources and different tastes, there's only one person. And tastes have to change with income, otherwise there's only one commodity. So you have those two conditions to start with. So let's imagine we've got two consumers and two commodities, Crusoe and Friday, and coconuts and bananas. And Crusoe owns the bananas, Friday owns coconuts. Coconuts are the necessity, bananas are the luxury, and Friday's got a higher preference for coconuts than Crusoe. Keep all that in your head? I don't think so. Let's take a look. Well, start with some arbitrary price ratio. You get your indifference curves there. Keep the aggregate income constant, so I'm not changing how many coconuts there are and how many bananas there are. And just have a lower price for bananas. Crusoe, who owns the bananas, is going to have a fall in income. Friday is going to get a rise in income. So the market demand for bananas could fall because of the lower price, because Crusoe's got less income, Friday has more, but he has a lower preference for bananas. He spends more of the money on coconuts. Similarly, trying to keep relative prices constant and increase income equally, you start from this situation, so we're now moving income out. So we increase the number of coconuts and the number of bananas in exactly the same proportion. So we move it out. Hello, what's happened to my graphics there? Okay. Okay, Crusoe's income rises more than Friday's because the bananas are the luxury. So you can't compensate for the income effect. So a uniform increase in income alters the distribution of income because one commodity is a luxury, therefore gets consumed more than relatively to the necessity. So you put that all together, and what you get is the only way to avoid this is to assume consumers all have the same tastes, so there's only one consumer, and the tastes don't change with income, so there's only one commodity. But if that's the case, there's no prices either. So this was such a profound contradiction. I think it's actually probably the most important result in neoclassical theory. Ignored by most neoclassical economists, even though it's covered in the major textbook called Nass-Colell, the result is ignored. One economist called Alan Kerman, I think, did the best interpretation of how you should look at these results. And he said that if given this result, the whole idea that we can start from the isolated individual has to be abandoned. We have to instead start from groups that have relatively coherent behaviour. And that means social classes, which is what the classical economists used to do. Workers, capitalists, bankers, rentiers, and so on. That's what should have been the reaction to this result. Instead, it was buried. And this whole idea of representative agents, which turns up in macro, was a bastardisation of this result, as if the result was successful. And you could use a representative agent to model the whole thing. So we have an enormously flawed theory. And I really regard neoclassical economics as being like Ptolemy's theory of astronomy. Okay? It looks like it explains the real world. It matches it in some superficial ways, but it's fundamentally wrong about how the nature of the world works. So we need a Copernican replacement to that model. And in the meantime, because we don't really have it, there's certainly beginnings of the theory there, but it's not complete. You need to learn all the theories. Pluralism is the order. And I know to some extent it does happen here at Glasgow. So I'm not going to go around trying to poach students from elsewhere, but you have got a course that teaches a bit of post-Keynesian. There is some elements here, so I'm not going to try to poach all of you, but I'm going to do as much as I can of this at Kingston. So maybe you might join me one day. Thank you. So if anybody survived that,